Okay, so hello and welcome. I've got the volume up quite a bit because, well, a few reasons. One, I have a machine running here, and it's gonna be hard to hear me, although actually that volume affects both, so it's not really a good reason. But the issue is I want to keep my voice kind of down, keep my voice low. It's kind of late. But yeah, so thanks for watching, coming by. Let's get right into the problem. So specifically, we're looking at, we were stuck the other day for a while, or I was stuck the other day for a while, and I realized a few things. One, don't need this jump array. Two, the onion thing that I was doing is kind of silly. Probably should just condense this. Still gonna use monikers for this problem, but we're going to use a quadratic running time, even though it's 2000 values. I think if we do a DP solution, we can actually make the running time with a quadratic solution. So I couldn't really think of something better than quadratic, but I think that's all we need. Monikers odd even, and one more issue here is this the right formula? That's what I want to double check for monikers. Double check that's the right formula, and then we're gonna write a DP solution and give that a shot. Try to solve this today. Okay. Also, these could be L and R here as well. Okay. So now is it R minus I plus 1 every time? I is greater than R. If this is too big, yeah, this could be too big. What do you default to? R minus I plus 1. That is actually incorrect on my part. Because we are to the right, this should be minus 1. Right, because in the explanation they were saying there's two centers for the even. There's a left center and the right center. We're on the left center, so actually we need to if we exceed the left side, then I'd actually be +2, not +1. I'm actually not sure. I feel like I need to draw this somewhere. If we're here, and our even value that we calculate, let's take something like this. Should be able to think this through in my head, but let's say this whole thing was a palindrome, and let's say the 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, this is just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's do 10. So let's say, quote unquote, our palindrome is this piece. The middle of it is going to be here, or actually, I could just think. I guess I could do this without a picture. I should have actually used paint for that, but that's fine. Let's say it's some L and R, and there's a midpoint which is slightly to the left. I plus j is going to be equal to L plus R. For a given I is, let's say, just a few values to the right. Let's say it's 2 or 3 to the right. So j is going to be to the side of. So that's kind of interesting. If I was one more than the midpoint, call that M, which is slightly to the left. If I was only one more, then its mirror would be, so let that value be M, that midpoint. So M plus 1. So we're saying I plus j is going to be equal to L plus R. That gives you the mirrored position. I believe so. Or I is M plus 1. So L plus R minus M plus 1 will give you j, which should be just M, right? How does L plus R relate to M would be the question, I guess. Think about that for a second. Yeah, let's say, I don't know, we could say 0 and 10. 10, oh, excuse me, minus I. J is L plus R minus I. Right. So minus M minus 1. M is L plus R divided by 2, roughly. See, if we're to the left, it's L plus R divided by 2 floor. If we're to the right, it's L plus R divided by 2 the ceiling, raise the ceiling. It's also L plus R, if we're only dealing with even palindromes, is necessarily an even number. So you can always divide by 2. Is that right? 0, 1, 2, 3. Give you 4 characters. 3 plus 0 divided by 2. It's not always even, but it's actually always odd. So you can take the floor, take the roof. So we take the floor, that should give us M. So L plus R divided by 2, which is the same thing as L plus R plus 1 divided by 2. Is M. No, if you take the floor, it's actually subtract 1. Is that right? Yeah, you subtract 1. So L plus R minus 1 divided by 2 is equal to M. So if that means that L plus R minus 1 is equal to 2M, L plus R is equal to 2M plus 1. So we take 2M plus 1 minus M minus 1 gives us M, which is what we're looking for. So that actually does work. That still works. This calculation still works fine. That's kind of what we're looking for. And we did, if I was M plus 2, then you do minus 2, you do minus, so everything you add to M to the right side, you would subtract from the center. So that still works. That mirror calculation still works, which is interesting. Now the question though is, R minus I plus question mark is how far to the right we can actually go with certainty. In other words, if the mirrored palindrome goes too far out, then we can only take what we know inside of our bubble. I think it's actually r minus I plus 1 is still correct, actually. And the reason for that is, like, I don't know, well, yeah, if our bubble is like towards the right side, our center is on the left. That's okay. If we have one iteration, that means we have another character to the right. 2 iterations puts 3 characters, 3 iterations puts 4 characters. Just thinking here, we're saying that r minus I plus 1 is the number of characters between where r is and where I is, inclusive. And that's also going to be the largest possible palindrome that we can have that's centered at I. Yes, that's still true. That's still true. Because I is moved to the left slightly, that actually doesn't give us any problems. Which is weird. You would think you might have an issue there. Like, that's what I was just observing, but actually, because I is the center in both cases. So there's a character at I in both cases, and you're just counting how many characters to the right of I, or including the center and to the right. I don't know, man. Something about that. When it's odd, it's pretty simple. When it's not odd, no, it's not. No. It does change. If I move this to the other center, on the even side, I think this does have to change. I don't know if it's subtract one or add one, another one. The reason for this is the even center has an extra character at 1. There's 2 characters there at 1. The center and to the right. If you're on the right center on the even case, at 1 you have a character at that spot and a character to the left. So you have one more character moving to the right. So you need to make your total smaller. Yeah, I think it's correct to do r minus I. It's very subtle, but I think it's the truth. And also, how are we doing on time? Yeah, that was a correction I think I needed to make, because I wrote my monikers algorithm a little slightly differently than the one they gave us. And then we also need, this is the same, but we need I plus k greater than r. I think this is slightly different too. Well, you decrement k. Is that right? The I plus k is the new index for the right side of our. See, that's really interesting. On the left side and the right side. So by the way, I think we're actually on the left center rather than the right center. I want to be on the right center, but I think we're on the left center. Because this is I, and this is I plus 1. I and I plus 1, and you're adding k to I plus 1 and subtracting k from I. So I and I plus 1, and then you're moving outwards. I don't actually think actually in this case I would be on the, are we using the left center or the right center? We're using the left center. They use the right center. We use the left center. Yeah, we did this. Yeah, that means our I is on the left side. Right, that's correct. We did that right. Problem with that though is I plus k plus 1 is now our rightmost character. You decrement k for E, but this should be decremented one more time too. No, because this is the position. I plus k plus 1 is the position. No, that's fine. We're exceeding where we are exceeding R. And the left side is I minus k minus 1. I actually think this should just be I minus k, because I minus k is also that other character, but we decremented k. I'm actually really confused now. I plus k plus 1. Oh, I'm sorry. This is not true at I plus k plus 1. So it's I plus k is the position that we also decremented k here. I think we don't need to decrement k. Right? And now or maybe we do. That's super confusing. The last position that worked was I plus k plus 1, and then we just incremented k. So I don't need to do I plus k plus 1 here or here. Yeah, because yeah. So this, once it fails, it worked when you decremented k once. That was the last time it worked, but this is still I plus k. So this could be what it is. And then over here, yeah, we need to get this right in order for this to work properly. Before it failed, we were at I minus, we'll say k prime, and then it failed at I minus k double prime, or I minus quantity k plus 1, which is I minus k minus 1 is where it failed. And so And so, oh, the reason why you decrement, oh, I see. Actually, the reason why you decrement k is so you could just use exactly these values in here. Oh, I understand. The reason why you decrement k is because this is the last time it worked at these indices. That's super simple. Okay, that's the easiest way to think about it. You just undo the last addition to when it actually worked last time, which is I plus k plus 1 and I minus k. That's a lot easier to think about. Okay, I like that better. Yeah, it's a lot easier. All right. Next is, I do think you decrement. That's trying to figuring that out, that you had to decrement by 1 is like kind of mind blowing. The reason why is because you have one more character per k. That's why. So you have to do 1 less k. All right. What we want to do, and I think, yeah. Okay. Anyway, so what we want to do, so we're saying a DP solution is the way to go, and I'll explain that shortly, what this is going to look like. So we're going to have an array, and we could say DP instead of array, which we did that last time, but I forgot it this time. Size, so we could say int n. We could say dp of I is equal to, so we have 2 values. So we're going to also write a subroutine. We're going to say auto is palindrome, or palindrome. How are we doing on time? Yeah, it kind of took me forever to think that through. I don't know, Moniker's algorithm is kind of like not the most. It's intuitive, but it's challenging. I would say it's just challenging. We'll just put it that way. All right, so we have a palindrome. We have these are going to be strings from right to left. So if some index left side. If we're going from right to left, you have a left side. That's left index. And we're going to say, actually really, yeah, no, that's fine. So the way we do it is we take the size of the array, or the size, characters, or count. And that's going to be that left index, so it's size minus 1 minus left plus 1, or just size minus left. So that gives you the rightmost index minus left, and then plus 1 inclusive. So that gives us the count for our palindrome. And now we're going to say, or we could just say mid as well. Count. If it's odd or it's even. So this is if it's odd, and if this is if it's even. So odd. Actually, that's kind of evident from I'm just going to return false here. So that's evident from this expression. So now we would say odd or even. If it's odd, we're going to check the odd palindrome. So we're going to say So what's interesting is the target is going to be count divided by 2. And on the other side, I think it's also count divided by 2. It's count divided by 2 minus 1. When it's interesting when it's even. So if you're looking at an index and you're looking at an even palindrome, the number of characters, if you have even of 2, that means you have 2 iterations. That gives you 4 numbers. So you do 4 divided by 2. That's if you're even. Yeah, if you're odd, you okay. I did it wrong. I did it incorrectly. So you do. I think the target would be count minus 1 divided by 2 if it's odd. So if you have 3 numbers, you're looking for 1 iteration. Count plus 1. If you have 3, you have 2 iterations. I think that's how we do it with the odd. It's 1 iteration is the first, 2 iterations is 3. So you gotta add 1 and divide by 2, which is the reverse of multiplying by 2 and subtracting 1. Yeah, that's what we're trying to do. We're trying to reverse. So it does matter which side we're on here, and we'll say that's the target. So we want return even of this index, and we have to find the midpoint as well. We'll come back to that in a second. Is greater than or equal to the target. So basically, we're checking to see if there's a palindrome and that's actually odd in this case, that there's a palindrome. Oops. That there exists a palindrome that's large enough for what we're trying to do. Yeah, the idea is, and you get, oh, TikTok needs you. Hello, Chris Coffee. Welcome. Are you a bot? Are you a real person? TikTok needs me? I'm not on TikTok. I don't use TikTok, man. TikTok it's not for me. You can also make this a ternary operator too, which would be good. You could do return count and 1 equals 1, and then we can take this one or this one. Yeah, this is better. Tricky thing here though is this midpoint. There's one issue here where the midpoint of O and E, so if it's O, we actually want to take left plus s dot size divided by 2, and I think this is actually the right. So the reason why I wanted to use the left side, by the way, is the reason why I wanted to use the left side, the left center rather than the right center, is so that I could do this, perform this calculation. I mean, among other things, but this calculation is very simple. So that's size. So the rightmost index and the left index, you add the two of them, you take the midpoint of the indices. Now, if you're looking at an odd palindrome, let's say it's 3 characters, so you'd have something like 0, 1, 2. Take the midpoint, you get 1. You'll always get the midpoint for odd. If it was like 0, 1, 2, 3, you're gonna get the left midpoint with integer division. By the way, you could just bit shift to the left 1. That's a slightly more efficient way of doing this. And when you bit shift, you got to be careful to make sure your parentheses are set up properly. Okay. Yeah, I tend to forget what the precedence of this is, what the operator precedence is. Okay, so this will give us a constant time check of whether or not we have a palindrome using Moniker's algorithm. Yeah, and then that'll allow us to write a DP solution that's relatively fast. So we're going to say if, and we're going to go from back to front. So n minus 1 greater than or equal to 0, decrement I. We're going to say if palindrome of I, otherwise, so we said dp of I equal to 1, or we say dp of I equals, we're going to say standard numeric limits of int max. Okay. Now the dp is going to be a similar thing. We're going to say int I equals n minus 1, I is greater than or equal to 0, decrement I. Say for int k is the number of characters, k is less than or equal to n, increment k, and then we're going to return dp of 0, and it's going to be, how are we doing on time? 30 minutes? Okay. And we're going to say if palindrome of, it's going to be, oh, actually, we could say left, right, or we could do AB. It's probably better. I should have done it this way, I think. So it's not size, it's going to be B minus A. Same thing, A plus B. Oops. Ooh. It's my bedtime. I think this still works. I think this still works. Palindrome of I, it's actually going to be A and B, so it's I and n minus 1. And so we're going to do something similar here. We're going to say K is the number of characters, I is to the right. This is actually I minus K, if you could imagine that. So if K is 1 plus 1. Yeah, if K is 1, then it's going to be A and B are going to be equal to each other. If K is 2, then you subtract 1 from I and move it, shift it to the left 1. Yeah, so that should be I minus K plus 1. So when K is n, you do I minus n plus 1. That's also, K is less than or equal to n, and I minus K plus 1 is greater than or equal to 0, more or less. So we're not going to go too far off to the edge either. And so if we're a palindrome, then we can say dp is going to be equal to the following. So we can say dp of I minus k plus 1, and that's going to be updated to the minimum of itself. And one issue here also is dp of I plus 1. So this is kind of interesting, but basically you're going to update this value to the minimum of itself, and the spot you're sort of considering the next section of it's actually going to be I minus 1. Or I plus 1 rather. So that's interesting. So, okay. That's peculiar. So, because it's not going to be at that particular character, it's going to be, yeah, so we actually need to have one more. Just make that 0. Something like this is what we want. I don't know if this runs, executes, works, etc. May need oh. Whoops. Huh. This is multiplying by 2, by the way, not divided by 2. That's also my mistake. Okay, not the correct answers. Not correct at all. I guess we can start with just AAB. Give me a moment. Now, I wasn't expecting this to be wrong as much as it would be slow. Whoops. But surprise, surprise, is my alright, anyway, just gonna delete this. Surprise, surprise, it's wrong. Wasn't expecting to be wrong. This could be wrong. dp of I plus 1 plus 1 for a given I. Minimum of what's currently there, and what could be added. Yeah, and this will never be this is never going to be int max. That was the thing I wanted to check. Excuse me. It starts off at 0 and yeah. It's interesting that in some cases I guess it could be. Just gonna refresh my chat. Can I clear my chat? I'm just gonna leave it. That's alright, we don't have to worry about it. We don't have to think about it. So, my question is, first off, why is this not correct? And second, what did I do wrong? It's definitely possible for this to be int max here. This is the check that I'm missing. That was right, because if this is int max, then there's no point in even executing this part of the code. I know that part's missing, but why is this incorrect? Is my question. So the idea is we're performing a dynamic programming like recursion where we're going right to left and we're taking every we're looking to record every palindrome from right to left. So B is a palindrome, so that means that we can DP 1, partition 1 there. AB is not a palindrome, AAB is not a palindrome, so each of those gets zeros, or each of those get those stay at int max, and then we start from the right side and we say if k is 1, take the palindrome of I minus k plus 1, which is just itself, right? And so this is really just to initialize and add. It looks like we don't actually need this part of the routine, but by the way, if we add this extra 0 here, I think that's fine. So yeah, so we would DP a single character at a time, right? K is 1. This should be true for every palindrome. And as long as this is less than the limits, so what's interesting is we would start with 1 character length palindrome, which would give us a 1. Then 2 length palindrome we would actually not get a 1 here or here, but the first routine would give us a 1, and then that's what K would we would loop through all the all the character sizes, so 1, 2, and 3. I minus 3, n minus 1 is 2. I minus, so 2 minus 3 plus 1 is 0, 0, 0, yeah. So then the issue becomes, or 02 rather, for that palindrome, which is not. Then you move over 1, right? You go to AA. I is now 1, or n minus, I is 1. I is n minus 1 minus 1. You say, okay, K is going to go from 1 to 2. Now, is there palindrome at AA? No. Or, yeah, for 1, A is a palindrome. So you would add the 1 to the right, add 1. So 1 plus 1 is 2. So dp of 1k is 1, I is 1, dp of 1 is 2. And then the next spot, this actually is a palindrome also, and you get 2. So that is interesting. That's how many palindromes. Yeah, so you have to actually subtract 1 because this is going to count the number of palindromes, not the. It's going to count the number of palindromes in the optimal split, not the number of splits themselves. I don't think that was the reason for failure, though. There were some other cases that didn't work. So we could say, like, let's take a smaller one that didn't work. 1, 2, 3, 4. 1, 2, 3, 4. The fourth one. This one? Now again, I'm actually expecting this to work. This is not supposed to be too hard at this point. This is supposed to be kind of a like not giving up, but like, yeah, I don't want to say giving up, but like we're trying to come with an algorithm that's not the best runtime. So we got 6 instead of 11. Can we just print each of these? Let's find out what's happening here. So we're going to say S is going to be S dot substring of I minus K plus 1 and I. And we're going to say I is I, K is K, is palindrome, is palindrome, we can say dp of I plus 1 dp of I minus k plus 1 something like this, I don't know. Okay, so here are all of the routines. So C, consider C, KC, so all of these are not none of these are palindromes, right? So the first 18, nothing happens there. So that's not true. The first one is a palindrome. That's interesting. The second one is also considered a palindrome. So that's a problem. That might be why things are too efficient. So I think maybe we made a mistake with our calculations here. Casey is that's the problem, or potentially a problem, potentially the problem. Okay. Oh, that's a lot closer. What happens if we calculate AAB again? Okay. Wondering if subtracting 1 is causing issues or not. I think subtracting 1 is correct, by the way. I think we're supposed to be doing that. So how did we get... We got 11. How come we didn't get 12? What do we expect for this? To get 11? Oh, it's this one. 1, 2, 3, 4, 5, 6, 9, 10, 11, 12. Okay. Or just 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, and then subtract 1 gives you 11. But we got 1 less than that. So let's get rid of all the stuff to the right. 1, 2, 3, 4, 5, 6, 7. Yeah, let's just get rid of all that, because it looks like all that's just there's no palindromes to be found there. How about this? Excuse me. Just yeah. To get the right answer here. Okay, so this is also off. We got 2, expected 3. Okay. And here we can do like 1, 1, 2, 3. Oh, excuse me. This 2 here. So it'll be 1, 2, 3, 4. We could do 4, which would be 3, which would they expect. But somehow I said 2. Okay. How do we get 2? So first things first. Are there any things that are not palindromes that are showing up as palindromes? BC is showing up as a palindrome. That's wrong. ABC wrong. BABC wrong. Okay, well that's not good. That's 2. So yes, the palindrome check's not correct. Interesting. Okay. This is correct, I think, the count. Mid. I think is also correct. Let's see, O of mid. That's a question. And E of mid. And finally, oh, we already got the count. Yeah, okay. Okay. Alrighty, let's do this. Okay. Just because that's a little bit disorienting. Okay, so count 1, mid 9, mid 1, emid, and this should also be substring s. So the ones that fail we want to look at, are the ones that false positives. For instance, AB, ABC. Okay. So the problem there, K is 4. Oh, wait, what? Oh, that's why. That's really disorienting. Okay. Alright, this is still wrong though. This says it is a palindrome. So AB, there's another palindrome check here. Can we just make this check? So things aren't too confusing. So BAA, BAB. It is a palindrome. It's not true. So the count is 6. 1, 2, 3, 4, 5, 6. Mid is 5. Mid 1, mid 3. So BAA, BAB. BAA, BAB. The value is I is 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. So K is 6. So 8. 7, 6, 5, 4, 3. Right, 6 characters at 3, so it's 3 to 8. That's A to B, it's 3 to 8. We said the count is 5, which is wrong. No, count is 6. We got that. That's fine. We got it. The mid is 8 plus 3 divided by 2 is 5. Ooh, that's wrong. This gives us the right center. 3, 4, 5, 6, 7, 8. No, it gives us the left center, which is the correct one. E mid is 3. Now maybe that's wrong. Maybe that's definitely not right. E mid shouldn't be 3. O mid is fine. That's correct. It's just 1. Well, O mid though is, yeah, O mid is fine, but E mid is way off. I had this issue before too. Did I get this wrong? I know I got the even part wrong. But why? It's 4. BA. No, it's just one more. Okay, it's not that's wrong. It's the somehow calculating this incorrectly. I think these might be wrong. Is that the typo there? BABAB. That's what we're looking for. E mid is 3. Now how does that happen? So something's wrong with my monikers algorithm here. Something's wrong with my monikers algorithm here. Are we sure about this? I had this calculation before. I don't know how I got this. I don't think this is correct though. What? What? How is that possible? What? This one is correctly 0 now. I don't understand a thing. I don't understand a thing. No, sir. Monikers is just beyond me. That's all I can say. It's just confounding. How is that possible? I'm sure this is correct. But what about, brother? Absolutely confounding. Oh. Okay. I think it's right. But my question is, why is this the way it's supposed to be? So, for some reason, we keep incrementing until we break on the right side. We'll say I plus k is greater than r. If I plus k is greater than r. Now, why is it I plus k? So we decrement k now. K represents what? K represents the number of iterations that worked. Decrement k, so yeah, still want the number of iterations that worked. I plus k, when k is 1, I is, let's say, 5, add 1, that counts both characters. Each iteration after that, you add another character. So I plus k is the right number. Oh, that's the spot for r. And then, for some reason, you decrement that also by 1 for L. If k is 1, leftmost character is actually at I. So yeah, you do I minus k minus 1. Excuse me, because when k is 2, the leftmost character is only 1 to the left. So you subtract 1. Is that right? If k is 1, you're at I. The left side's wrong. I think this is plus 1. Nope. That's confusing. This is so confusing. So confusing. I don't know. This is definitely not correct. It's definitely not correct. Somehow this is wrong. Somehow this is wrong. Excuse me. If I is 5 and k is 1, we're on the left center. I is 5, k is 1, left center. We decrement k. So let's say k is 0, right? These match. K increments to 1. Okay. Set this to 1. And now when we calculate, we decrement k by 1 first. So we say I greater than r. So this is wrong. This is actually incorrect. This should be plus 1. Because we're on the left side, which means we have one character to the right, which is so we don't actually need to do this. Yeah. So confusing. How do I do this quickly? That's the problem we keep running into. Like, how am I supposed to do this quickly? Like, there's no way to do this quickly. This is just like mind-numbing. Also, I really need to go to bed. R is I plus K. Okay. Yeah. If I is at index 5, then I plus 1 is at index 6. Alright, that's the next character. There's 2 characters. Three, 4, right? You increment K, you keep incrementing more. If that's greater than R, then we need to update R to that. And on the left side, if we have 1, then it's actually plus 1. Yeah. This was correct the first time I did this. I think. Somehow I'm just wrong. I don't know. Okay. If we're at 5 and we have 1 iteration, then we're still at 5. I minus 1 plus 1. That's the left side, inclusive. If we had 2 iterations, then we would subtract 1 more, right? To do I minus 2 plus 1, right? These are the correct bounds for R and L, but somehow we get the wrong answer, and it's making me crazy. It's making me crazy. You're making me crazy, man. You're making me crazy, man. Just gotta get back out, get the debugging code back out here. Where am I going wrong? How is it possible that this is not the correct way to get left-centered even palindromes and calculate those correctly? So let's say I is an 8. Excuse me, I gotta go to bed. So if for some reason we get E3 here, we do this. This doesn't make any sense. I don't know, man. So confused now. So confused now. How? Let's just debug. Okay. So we got I have 0, E of 1, correct? I have 1, E of 1, correct? I have 2, E of 0, correct? I have 3, 0, I have 4, 3. Okay, that's definitely not correct. 1, no. No, 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 no. That's why. This algorithm. Four, we said 0, 1, 2, 3, 4. Oh, no, it is. Oh, it is 3. Oh. Whoops. Excuse me. Uh-oh. Uh-oh. Whoops. I see. Oh, that's interesting. And then 5 is this one. And that, okay, that's not supposed to be 3 though, so wait. This one is 3, right? Because 1, okay, that's really interesting. But the next one, 5, is not supposed to be 3. Okay, that's the issue though. 5 is the issue. The reason why 5 has 3 is because 5 is in this bubble, ABABA. Actually, I think the calculation is this L plus R minus I and R minus I. This actually has no palindrome for this guy. That's really interesting. Because it's supposed to be mirrored, but it doesn't quite work like that. Yeah. That's kind of weird. That's kind of weird. How do you figure that? How does that happen? So R minus I is what? When I is 5 here? R is the negative number. I is 5. R is like way over here at this point. Yeah, it's actually at it's at this guy, which is 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6, 7. It's all the way at 7. R is 7. I is 5. So that should be 2. What's R and what's... Let's do L and R. I'm calculating something wrong here. Well, this is over an hour now. This is supposed to be kind of an easy one. Okay. It's alright, monikers, never easy. So, L is 2, R is 7. 0, 1, 2. And then 1, 2, 3, 4, 5, 6. So that's correct. That is actually right. 2 and 7. 6 characters in between. We're looking at I is 5. L minus R is, L plus R minus I is 9 minus 5 is 4. So E of 4, right? 3, correct. And then R minus I is 5. No, 2. R minus I is 2. Which is what we expect. We are 2 away at that point. I is 5 is here. 2 characters to the right is exactly correct. Or 2 iterations. If we had 1 iteration, 2 iterations. Yes, 2 iterations would put us at the edge. Exactly correct. So it should start off at 2. Now the problem with why this is starting off at 2 is that's kind of an issue. I think have a problem here, huh? It actually... Because our center is not in the same spot, right? The center is on the other side. It's a totally different calculation now, because we can't do AA, we can't even do AB. We actually end up with 0 here. Now the question is this actually a bug in the monikers, or is this just a bug in how a counterexample, or is this just a problem with how I formulated this, how I wrote it? I think it's probably a problem with how I wrote it. Yeah, actually you're supposed to be able to use, because you can do AA, well, yeah, yeah. If you mirror across, this is actually 0, this one. Huh. That's really weird. I gotta sit and think about that for some time. Ponder that one. Why would... Why would you not be able to use the mirrored... That makes a lot of sense if you have a an odd palindrome, but for some reason even palindromes don't work if the center is on the left side. I don't think the algorithm works if you're on the left side. I think that's the problem. It actually doesn't make sense. You need to be on the right side, because if you try to mirror across and your center is on the left side, you don't end up in the right spot. I think that's the issue. If you're... Oh, no, that's my problem. That's okay, I got it. So yeah, so basically you're supposed to mirror across the palindrome, which is weird, but that's because if it was... That's so weird. If this was the right side, then you wouldn't even have a bubble here. You wouldn't even have a palindrome on this right side. It would just be this guy that on the right side has a palindrome. Oh no, excuse me. Yeah, on the right side it would be this one has a palindrome, and then you wouldn't even try this. Well, this would be mirrored across this guy to here, which doesn't have anything. So basically I'm not mirroring it far enough across. I think that's the problem. I think you have to subtract one more if you're on the other side. Oh, never mind. Yeah. If we're on the left center, we want to mirror across. I think we actually need to go... Alright, Alright, this value compared to this center should actually mirror to here, which has nothing. Yeah, I think it's actually got to jump over. And what's awkward is that, yeah, if you don't use the right center, then when you have to subtract 1 here, and the issue you run into is, you you run into a problem here. If I is less than 1, if I is, yeah, if L and R are 0, that's kind of interesting. I is greater than R, which it is initially. Then I ends up at 1 the next iteration. And L and R are non-zero. This shouldn't happen. What's going on here? I is greater than R. Calculate 0. I is 0 is greater than R. Oh, I see. Oh, this is going to evaluate this. Okay. Could just add an extra 0 in this value. Should at least work if we do this. Okay. Excuse me. Could do another assignment here. To save us this execution. So I see why they would want to use the right side rather than the left side. I get it. I get why they would use the right instead of the left. Oh, excuse me. I is always greater than. I see. I see the problem. Initially, I is greater than R. That's why. Oh, I see. See the issue. Now our answers are correct. Yeah, you save a little bit by going to the right side instead of the left side. I should do that next time. I should do that next time. Probably shouldn't delete all that code. Probably might need to debug a little bit more later. I see. So many pieces involved. So many things to get wrong. That took a while to figure that out. It's really interesting. Oh boy. Okay. This might not even be totally correct, by the way. I think we're fine. This really should be, if this is a negative number, then use 0 instead of this. It should be kind of a different statement altogether. I think it's okay though. I think it still works in the context. Because E of 0 is pretty much always going to be 0, I think. It could be 1. But it's always going to be It's either 0, 1, and then r minus I is -1. Oh, that's interesting. Oh, wow. But no, but I is always greater than -1 though. So you should get 0 anyway. I don't know. This is just to to make sure we don't, when you calculate this, I think it calculates both expressions. I don't know. I don't know what's going on there. I'm not gonna worry too much about it though. I think it's fine. Okay. So this was not supposed to be this difficult. Yeah. It's not supposed to be this hard. Yet it was quite challenging. So there's one speed test we want to check out. And that's going to go something like this. X for int I equals 0, or not int, just I equals 0. I is less than, we said 2000, right? Increment I. We're going to make x equal to ax, and then print x. Okay. So our algorithm runs slowest on an input like this. We're going to find out whether or not we TLE. That's the question. If we TLE, then we're toast. If we don't, then we can submit this solution. Okay. Actually, that's a palindrome, so this is still pretty fast. Need something that's not necessarily a palindrome, but very palindrome-like. Okay, how about that? Has palindromes involved? Only one cut that was needed for this. I don't know. How do we get like? Maybe we can get some like random characters or something. That's like a really bad test case. Let's go for this. So actually what's interesting is the DP algorithm doesn't terminate early. So I don't know, do we just go for it? I think we just go for it. Hey! I spent so much time on this. Brother. Could have solved this in like 5 minutes. This could have been done in like 5 minutes. Oh, this is so simple. This is such a simple solution. Oh man. I'm just sad now. Wow. That was really fast. Really fast. This isn't linear time, by the way. This is quadratic time. But I think it's really fast because of the if statement. Makes it really quick. Okay. Alrighty. Yeah, you know. Okay. Brother. This is just upsetting. This is just depressing. You just go lay down now. Dude. What? What? Of course. That was really easy, and I spent like 2 full days just pondering this question. You gotta be kidding me. That wasn't supposed to be that hard. Oh, man. Wow, that's wild. This is challenging. It's difficult. It's difficult. By the way, I had a conversation with my, well, I'm not get into that. We'll just say something is on my mind, has been bothering me. Because I made a big mistake and didn't realize it. Oh, not related to this problem, but something else going on in my life. It's a minor mistake. Of all the mistakes I've made, it's a pretty minor one, but it's really annoying that I made it. Yeah, so that's alright. Should be okay. Overall should be okay. So, oh man. I can't believe I spent so much time on that. I guess I learned something, right? How monikers is put together. You can't do the left center without running into an issue. And what's the other part? Yeah, the DP was fine. That wasn't such a hard problem at all. It wasn't supposed to be that hard. I think what I forgot is that I've been solving the problems without using DP. I've been using recursive memoization instead of a DP solution, and the DP solutions are just like way faster. So it allows you to do a quadratic time algorithm on something like that. Wow. Yeah, I don't know, man. I don't know what to say other than like, oof. Oh. Should really use monikers on the right side. Should be on the right side. Let's look at that quickly on the right side, what that would look like. Quick peek. On the right side, this you'd add 1. It would still be L plus R minus I. It's R minus I plus 1 on the right side. This is minus 1 here and O plus 1 there. Decrement there. These are the same. There's no decrement here though. This is all just the same. This bottom part's all the same, I think. May need to add 1 here. I don't think so though. No, you're fine. Be decrement here. This is decremented here. It's decremented here. Yeah, your decrement K, you get the same value here. I think this might be different. This might be I minus K. This would be, yeah, this would be I minus K instead of I minus K plus 1. I think this bottom part's all the same. Top part's the same, bottom part's slightly different. There's a minus 1 here, and minus 1 here, and no plus 1 here. And then you just have to modify the midpoint that you select for E. I think you just add 1 here. potentially. Yeah, and it would just be 0 if the midpoint is to the right. Yeah, if the midpoint is just too far to the right, then it's just 0. So if a plus b is if mid plus 1, if this, so you could just put a check here if it's greater than or equal to if it's greater than or equal to the rightmost bound, then you just return 0. Actually, if it's, you just return false. Actually, in that case, you could terminate it early. But yeah, that's kind of the only change I think you'd make. Just add 1 to mid plus 1. If mid plus 1 is too large, you terminate it early. And let me just check on monikers. Oh, excuse me. L is -1. Yeah, it's almost the same. L is just -1. It's interesting that we add 1 here. That's kind of weird, but yeah, it makes sense actually, because we decrement, so that's really weird actually. Yeah, it should match I minus k minus 1. I think this might be wrong actually at this +1. It doesn't seem to matter very much, but no, I don't know. I got it right. I don't know. Maybe this one's wrong. No, I minus k minus 1 is definitely what it should be. It should be those bounds. I plus k and I minus k minus 1. Same thing here. It should be I plus k and I minus k. I don't know. I don't know why there's a +1. I think the reason why there's a +1 is actually, is this still correct if we do? It might just be an accident that this works the way that it does. I'm actually really confused now. No? Hold on, what? Why is this not the right answer? Oh, it is right. Okay, yeah, this is supposed to match these bounds. That's okay. The reason I kept messing around with that is because of it's actually because of this error. I didn't realize it was this error was the problem. I see. Got it. Got it. So yeah, that's okay. So this bottom part's pretty easy. Just decrement k and then use the bounds you had here. This top part's a little tricky though. If you move to the right, you have to just subtract 1 on both sides for the correct mirror. and then if you move to the left, you don't have, it's the same. So this is a copy of this part's the same. You can use monikers, you can use a quick palindrome check and perform a DP, and 1, 2, 3, you're done. So it's actually like pretty straightforward, pretty easy, this question, but I really struggled. All right, I gotta go. Thank you for watching. Talk to you soon. Have a good rest of your day. I don't know, man, just contemplating my existence has been interesting. Let's just say it's interesting. Let's go with that. All right, I'm gonna go. Take care. Bye.